36 subtract, you get 1, a remainder of 1. Remainder of 1 is going to be just I. Okay? I can do it on the calculator for you, and it comes with a little bit of an error problem. I'll show you what happens the way it happens. I'm just going to go I to the 437 power. Here's I, exponent 437. You end up with a value something like this. 1.3 e minus 12 plus I. That's a minus right there. Okay? Let me rewrite this. 1.3 e negative 12 plus I. That portion is due to the error because it's trying to figure, after at power of 6 you get an error involved. Like if I go I to the 7th, whoops, excuse me, I, and then raise to 7th power, you end up with a little bit of a problem right here, okay? So what this means is this 1.3 times 10 to the minus 12, we know that that scientific notation is approximately 0.0000000013. So this portion is 0 right there. 0 plus I, ended with I, which we should have gotten in the first place. So you could actually do it with a calculator if you want, or if they don't allow you to use a calculator, you have to do it manually using long division. Don't forget, this is the remainder of 1, remainder of 2, remainder of 3, remainder of 0. Okay? Let me see. So I don't like the way they actually do it in the book. A lot of teachers, they like to use this method right here. Okay? It's going to go through the cycle 109 times with the remainder of 1. Let's multiply some problems now. Example 6. You end up with 3 minus 4i times 2 minus 5i. You're going to 4 this out. So 3 times 2 is 6. 3 times negative 5 is negative 15i. Negative 4 times 2 is minus 8i. You notice I used the vertical format. The outer and the inner usually adds up. Minus 4i minus 5i is plus 20i squared. Drop it down. 6 minus 15i is minus 18i is minus 23i. What is I squared? We know that I squared is negative 1. So here's a little trick that I use. I just get rid of the squared and change the sign in the top right there. Okay? So instead of plus, it's going to be a minus. So let me get my nice pen. Minus 20. And we're going to try to write this in standard form. 6 minus 20 is negative 14 minus 23i. I'll show you how to do this on your calculator. Make sure I get that shine out of the way. 3 minus 4i, there it is, and then divided by, multiplied by 2 minus 5i. There it is right there, something like that. And 3 minus 4, I don't have to put that in parentheses, I work it out. I end up with negative 14 minus 20, minus what? 23i. Negative 14 minus 23i. Perfect. Okay, so there was example 7. Example 6, excuse me. Let's do example 7. Example 7 is kind of neat. There's a reason why it's kind of neat. So you have 4 minus 5i times 4 plus 5i. We've kind of seen this before. These factors are very, very special. One has a minus, one has a plus. You notice these are called, if you learned in Algebra 2, sometimes in Algebra 1, these are called conjugates, because one has a minus and one has a plus. And they're very, very special factors. And I'll tell you about those special factors a little bit later on. For now, let's just fold it out. 4 times 4 is 16. 4 times 5i is 4 times 5i. We just multiply these two, becomes plus 20i. And then negative 5 times 4, negative 5 times 4i, we multiply these two, you get negative 20i. Minus 5i plus 5i is equal to minus 25i squared. Don't forget, I times I is I squared. What happens? the outer and the inner always cancel in conjugate. Don't forget, the outer and the inner always cancels in conjugate. So you end up with 16 minus 25i squared. But we know that I squared is going to be 1, so I'm going to use a nice orange marker for this. That becomes plus right there. So what is 16 plus 25? It's going to be 25, 35, 41. Okay. I'm going to use a calculator for this to try to see if we actually get the same answer. It was 4 minus 5i. So 4 minus 5i, and then multiply by the conjugate, which is 4 plus 5i, and we should get 41. Voila. Okay. Example number 8. It's a little bit more complicated. Got 5i over 2 minus 3i now. They're going to say divide this, and so what the heck? Can't do that. That's not right. You're not going to even use long division for this one either. So what we're going to do here is to get rid of the, what they're actually asking me to do is called rationalizing the denominator. When you're rationalizing the denominator, you want to make this a nice big integer if you can. And if you multiply by just 3i, you have to distribute with that 2. So you end up with an I. Always multiply it by its conjugate, 2 plus 3i. That's where the conjugate comes in. 2 plus 3i. Okay, and let's see what happens from now. On the denominator side, let's work on the denominator. 2 times 2 is 4. And then plus 6i, the outer, minus 6i. Always cancel. The outer and the inner always cancels in conjugate. And then minus 9i squared. Don't forget, 3 times 3 is 9. I times I is I squared. We distribute this out again. So you end up with 2 times 5i, or 5 times 5i times 2, which is 10i. And then plus 5i times 3i squared. 3i is going to be plus 15i squared. About 2/3 of the way there so far. Remember, I squared is going to be negative, so we just change the sign on that. I squared is going to be negative, so we just change the sign on this one. So let's rewrite this in standard form in the numerator. So it's actually going to be negative 15 plus 10i all over 4 plus 9 is 13, and we're almost done. We're going to write it in standard form. Standard form is a plus bi, so we have to break this one single fraction into its partial fractions or separate fractions. It's going to be negative 15 over 13 plus 10 over 13. Put your eyes in the back. Okay, that should be helpful to help you do example number 8. I'm actually going to, how long has it been? 22 minutes. I'm actually going to do maybe a couple of these problems out for you if you want me to. So let's do number 2. Square root of negative 49. We're going to take our i's out. It's equal to I times the square root of 49, which is 7i. Pretty simple. Okay, number 19 is a little bit tricky, very, very tricky. I really don't want to do number 19 because it's going to take a lot of time. Let's do number 19 or 21. 21 is going to be pretty difficult to do, so let's try to do this. It's going to take a little bit of time. Sine square root of x plus 1 plus I sine tangent of y is equal to 2 sine of x plus I. All of these problems I'm doing is impromptu, so I'll pick at random whatever questions that seems to be a little bit difficult. We know that this is the real portion right here, has to equal that real portion, and we know that the imaginary portion right over here, because you have an I, has to equal the imaginary portion right here. So sine squared of x plus 1 has to equal 2 sine of x. We know that the tangent of y has to equal 1, the real portion. This is the real portion of the imaginary part. This is the real portion of the imaginary part. Solving this out, you have to move this over because it's a squared. It's quadratic. Sine squared of x minus 2 sine of x plus 1 equals 0. We factor that. Sine of x minus 1 equals 0. Sine of x has to equal 1. X has to equal 90 degrees or pi over 2. Depends if you want it radians or degrees. For this one, tangent of y has to equal 1. Tangent of y is sine of y over cosine of y has to equal 1. We know that the sine over the cosine, that ratio has to be at 45 degrees or pi over 4. This is kind of like a little bit difficult, so make sure you can go y over x. The ratio of the opposite to the adjacent side must also equal 1. It only occurs at 45 degrees. Oh, we forgot one more thing. For this one, it's going to be 225 degrees as well. Quadrant 3, or 5 pi over 4. Whoops, forgot that one. Okay, this is quadrant 3. This is quadrant 1. Next problem is I to the 3341. I to the 33 power. Just take 4 divided by 33. 4 goes into 33 8 times, 32. Subtract 1. The remainder is 1. You know that the remainder 1 is going to be just I. Verify that on the calculator. I showed you how to do that. Let's try 47. Nice problem. 3 plus 2i 20 squared. You want to distribute that out. The same thing as 3 plus 2i times 3 plus 2i. Distribute, write it out so that you can actually see what's going on too. 3 times 3 is 9. 3 times 2i is plus 6i, plus another 6i, plus 4i squared. You get 9 plus 12i, minus 4, because I squared is negative, right? Get rid of your i's. 9 minus 4 is 5 plus 12i. Relatively simple. You can actually use it on your calculator. Let's see, right over here. 3 plus 2i. Parentheses, 3 plus 2i. There it is. And then square that, and you end up with 5 plus 12i. 5 plus 12i. And some of the back ones are pretty simple. You should be able to do some of them. 79 through 86 is kind of a little difficult. I'm pretty sure he's not going to have you solve them out. But for the most part, they're pretty simple. So good luck. And 8.1 wasn't too difficult. You actually learned about your imaginary numbers. What it is. It's not a real number. It's an imaginary number. Next section, we'll actually go into how to look at it on a graphical notation. Thanks. Bye.